Today we are reviewing factoring and exponent laws. If you've been coming to tutoring, then you've already been reviewing this, and it's the same exact stuff that I reviewed with y'all. So yeah. Okay, so factoring. I need you to pay attention. I beg you to pay attention. Okay, because anyways. All right, factoring. There's two different methods. One of them was the X method. And when can I use the X method? When A equals 1. So when that A value equals 1, some of you are like, what are you talking about? What's A? Okay, for a quadratic, ax squared plus bx plus c, when I'm trying to factor, if my A value, coefficient of x squared, if that equals 1, basically if there's nothing there, then I can use the X method. The X method says I can put the B value on top of the X and the C value on the bottom. And I'm trying to find two numbers that add to get me the B value, but multiply to get me the C value. Does this sound familiar? Yeah. I hope so. All right, anyways. So here the B value is negative 13. So I put that on the top. There's my B value. The C value is negative 30, so I put that on the bottom. There's my C value. So I'm looking for two numbers that add to get me this number, but multiply to get me this number. So I always say, write out your factors of the thing you're trying to multiply to. So the factors of 30 are 1 and 30, 2 and 15, 3 and 10. But it's multiplying to get me a negative and adding to get me a negative. So what does that mean about my numbers? One of them has to be negative, right? Because they're multiplying to get me a negative, that means one number is negative. Well, if it's adding to get me a negative, that means the bigger number is negative. So the combination, 1 and negative 30, no, that would give me negative 29 if I added those. 2 and negative 15, that would give me negative 13. So those are the two numbers that would add to get me negative 13, but multiply to get me 30. So what's my answer? M minus 15, M plus 2, because it could be X. So X minus 15, X plus 2. Those are my two factors. Pause. Questions? That's the only example I'm doing for that. So ask me now. If you don't remember, you need to write it down. Okay. There's no shame in writing notes again. Okay. But you just have to know I'm going fast. If I was to write anything, I would at least write this to remind you what to do. X method, put the B on top, C on bottom, what adds to give me B, but multiplies to get me C. This is something you cannot do in Desmos. I will start telling you what you can do in Desmos. I will start reminding you and we'll be practicing, but this is something that Desmos will not do for you.
Oh, but it was easier.
About 70% of the test can be, if you know how to use it, yes.
Whenever you were younger, the tests were easier. Did you have Desmos?
No. We just had those calculators. All right, guys. So quickly, go ahead and find the factors of this. I'm going to give you a minute and 30 seconds because we don't have time to do too much review today. If you did tutoring with me yesterday, unfortunately, this is the same PowerPoint, but you can practice and test yourself. Morning. Okay, one more minute. 30, are y'all done?
Yeah.
Oh, my bad. Okay, so X method. My gotta try to get on pretty quickly, babe. So what do I put on top? Do I put on bottom? Okay, so I'm trying to find two numbers that add to give me -7, but multiply to give me -8. Please, I beg you, take the time to actually just find the factors to make sure before just assuming. I know if it's multiplying to get me a negative, then one of them has to be negative. If it's adding to give me a negative, I know the bigger number is negative. So what combination would give me add to give me -7? 1 and -8. So +1 and -8. So my two factors are x plus 1, x minus 8. We good? Okay, moving on. Okay, what happens when our a value is greater than 1? Okay, I'm just going to go ahead and use this example, and I'm going to talk you through it. So this one's a little bit different. When my a value is greater than 1, I use the AC splitting method. Again, there's like a ton of methods. All you have to do is YouTube them, okay? But I use the AC splitting method. That tells me to multiply my a value and c value. So a is 2, b is 9, c is -35. So I want to find the product of a and c, so a times c. So a times c is -70, because 2 times -35 is -70. And the sum of the b value. So my b value is? So same thing. I'm trying to find what numbers would add to get me 9, but multiply to get me -70. So I'm going to list out the factors of 70. 1 and 70, 2 and 35, 7 and 10, 5 and 4, hold on, 5 and 14, 7 and 10. Hold on. So if it's multiplying to get me a negative, because it's -70, and it's adding to give me a positive, I know the smaller number is the negative. So I gotta see what combination would add to get me +9. -5 and +14. So now that I've found the two numbers that would add to get me 9, but multiply to get me a -70, I'm gonna split my middle term. So 2x squared minus 5x plus 14x minus 35. So I split my middle term with the two numbers.
Yeah, you multiply times that.
What'd you say?
The -5x and plus 14x.
Yeah, I think I would have originally, but I just wasn't paying attention. But I'll give you the same answer. Perfect. So I grouped them together, and I want to see what is the greatest common factor here. What goes into both 2x squared and -5x?
1x.
1x. Only 1 goes into both 2 and 5. So only 1x. So x times what will give me 2x squared? And x times what will give me -5x? -5. And remember, our goal over here is to get the same exact thing in the parentheses. So let's factor out something here. What would be the greatest common factor of 14x and 35? What goes into both 14 and 35? 7. 7. And so 7 times what would give me 14x? And 7 times what would give me -35? -5. Well, awesome. I have the same thing in the parentheses. So my two factors are the x and the 7. So x plus 7. And then what was in the parentheses? 2x minus 5. Here's my two factors. Now, reminder, guys, if it's a multiple choice problem and you have no clue what to do, you can take all your answers and just multiply them out and be like, okay, I don't remember how to factor, so I'm gonna take each factor and I'm gonna multiply it and see which one will give me my original number. Okay, if all else fails, do that, because I'd rather you do this and use all the answer choices than just get it wrong. So if I multiplied this back out, it gives me my original answer. So you can do that with all the multiple choice answers if you didn't remember what to do. Okay, Those are all the factoring we're going to review. Now we're going to go exponent laws. Ready? I'm going to do these very quickly, but I'm going to go ahead. I'm going to write them on the board after I'm done doing them just because they're on the formula chart. So, all right. Exponent laws. Product rule, the product rule, the product rule. This says when I multiply things that have the same base, I add their exponents. So x times x to the power of 4 times x to the power of 5. When I multiply, they have the same base. They both have x. I add their exponents. So 4 plus 5 would give me x to the power of 9. Look at this example down here and see if you understand. So 6 x to the power of 5 times 3 x to the power of 5. Well, 6 times 3 is 18. And I add their exponents because they have the same bases. And the 5 plus 5 would give me 10.
Oh,
Let's see, ask me questions. This is the time. This is the
I thought you
time.
were supposed to just multiply 6 times 5.
It's not,
Are we good?
yeah.
When I divide with things that have the same base, I subtract the exponents. So if I had x to the power of 5 over x to the power of 4, x to 5 minus 4 is 1. So that would be x to the power of 1. So when I divide and they have the same base, I subtract their exponents. So over here, see if you understand the example. 18 over -3, those aren't exponents, so I don't subtract that. Those are just dividing. So 18 divided by -3 is -6. But c to the power of 3 over c to the power of 2, they have the same base, so I subtract their exponent. Bless you, so it'll give me c to the power of 1.
So it is the power of 1. Would you like usually put a 1 above it?
No, I just did that for your benefit, but yeah, you won't ever see it. Yeah. All right. Next one is power rule, power rule, power rule. When you raise something to the power, you multiply their exponents. So when you raise it to the power, you multiply their exponents. So x to the power of 5, all to the power of 4. 5 times 4 would give me 20. So looking at this example right here, everything is being raised to the power of 3. So what I like to do, what I saw somebody do, and I thought it was really clever, if it doesn't have an exponent, that means it's raised to the power of 1. And if you know you're going to multiply, just pretend like you're distributing this 3 to everything in here, the exponents. So 3 to the power of 3, s to the power of 3, and t to the power of 2 times 3, which is 6. 3 to the power of 3 is 27, 7 to the power of 3, t to the power of 6. Observe it, see if you have any questions. Observe it and see if you have any questions. Are we good? All right. Next rule says anything raised to the power of 0 equals 1. Anything raised to the power of 0 equals 1. Anything raised to the power of 0 equals 1. So all of this is being raised to the power of 0, so it all equals 1. All right, we good? Last one, and then I'm done. Anything with a negative exponent, you don't want negative exponents. If it has a negative exponent, then it's not all the way simplified yet. So to get rid of the negative exponent, you would move it to the denominator and change it to a positive. So if you have a negative exponent, you would move it to the denominator and change it to a positive. So 2 times x to the power negative 4. I don't want this x as being raised to the power negative 4, so it got moved to the denominator. 2 still stays on top because 2 wasn't being raised to the power of any negative, only the x. So x to the power of negative 8, I don't like that, so it'll go 1 over x to the power of 8. You move it to the denominator. Okie dokie. Y'all ready for today's activity?